Hello guys, so this is the Bluetooth controlled biped robot. So if you want to see this robot in action, you could visit the consequent video or check the link in the description of this video. In this video I'll explain you how you can build one. Actually I'm going to remove all the screws and show you what's inside this. So now to give you an overview, we have 4 motors over here: motor number 1, motor number 2, motor number 3 and motor number 4. So this motor is called the left hip motor, as it controls the hip of the robot, and then this motor over here is called the right hip motor, as this controls the right hip, and this is called the right ankle motor, and this is called the left ankle motor. So if you're completely new to this video, please visit the article which can be found in the description of this video, where I would have explained the complete setup of this robot, and the codes, the schematics, the 3D printed materials, everything can be found over there. So this robot is completely 3D printed. So you can see we have our website's name over here, which is circuitdigest.com, and then a small robot design on the head of it, and then a small slot is left over here so that I can see if the Bluetooth is currently connected. The Bluetooth LED can be seen via this hole, so we can know if the Bluetooth is currently connected or it is just disconnected. On the back side we have 2 openings. One is the Arduino programming cable, which can be used to debug the robot as well as to power it, and you can also power this robot using a 12V DC adapter. You can connect a normal 12V adapter's jack on this hole. You can just connect it like this, or you can also use a 9V battery which can be kept inside the head of this robot. Okay, now let me unscrew all these and show you what's inside this. So here I have used duct tape for its feet to give the robot some grip over the surface. I was experimenting this robot on ordinary floors and over this chart paper, so it didn't have proper grip. The 3D printed material didn't have proper grip, so I used some duct tape so that the feet can get a proper grip over this chart surface. So that's it. So I'll just unscrew this robot and show you the parts inside. I'll just remove the duct tape first. This tape was used to secure the head of the robot. Okay, as you can see, this is a separate part. And now I'll remove the programming cable, and the programming cable is removed now. So now let's open it. We have the perf board over here, and the 12V adapter is connected over here. So let me remove the adapter. Okay, so this is the head of a robot. This is the head of a robot. So, and we have our perf board over here, which can be secured like this. You can also use 9V batteries to power this. For using 9V batteries, you can place the 9V battery between the servo motors and the board like this. So as you can see, the battery fits properly onto the base, so you can place it like this and then secure the board on top of it, and then plug it over here. So you can see the robot can be powered in this way also, so that way you can completely secure it and it doesn't need an external power supply. Okay, so now let me remove this. Okay, so let's take a look on the perf board. The perf board has a smoothing capacitor because we are using servo motors. Ripples are really irritating, so it is better to use a capacitor for the power supply. And then we have our Arduino Nano over here, which is kept in place using female bug sticks like this. And then the HC06 Bluetooth module, which is also placed using a bug stick. And all the 4 motors are connected to the pins as shown in the schematics. So we have 4 motors, as I said earlier, and all these 4 are connected. All these 4 are connected over here. So let me remove everything. Okay, so this is how your perf board would look, and at the bottom you can see that I'm giving a common ground for everything and a common 5-volt supply for the Bluetooth as well as the servo motor. The schematics can be found in the link which will take you to an article where you can find the complete code and the schematics. So now let me unscrew all these parts and I'll show you how I have secured the motors. So let me remove the tapes, and then as you can see there's a small hole over here which can be used to route the wires, as I have done over here. The wire from these 2 servo motors can be routed via this hole. So let me remove those wires out. So these 2 wires are for the ankles and these 2 are for the hip motors. So let me remove those wires outside. Now as you can see, we have the hip part, the feet, the 2 feet, and then the knee part. So totally there are 1 2 3 4 5 plus 6 3D printed materials. Now let me unscrew all these. As you can see, the motor is fixed using a screw and the shaft is also fixed using a screw. The screws can be seen over here. So most of the screws come along with your servo motor package, but you might need to get some extra screws. So now as you can see, we have 2 screws to secure this motor and 2 to secure this one, and the shaft is also secured with the 2 screws. Okay, now let me remove all the screws. This is how you should assemble it. So actually I dismantled it, but you can use this video to assemble it as well. So that's it guys, you can see this board in action in the next video, and the complete details on building this robot with the 3D printed designs, the program, the Android app to control it, everything can be found on the link of the description of this video. Thank you.